So here we are, as we seeing the basically the reactivity of the, we are seeing the over extraction according to the reactivity. Now we're gonna see basically for the uh, higher reactive metals. So for the case of higher metal reactive metals like the sodium, magnesium, calcium, and aluminium. Aluminium, they are also the higher reactive metal. Among this, sodium, magnesium, and calcium are obtained from molten chlorides. So what actually happen here, basically we use a electrolytic reaction here at cathode. You see the sodium, when you pass the electricity then sodium gets electron converted to sodium, and at anode chlorine negative, that is 2. Here chlorine plus electron is released and B, so reaction C is 2, like this form in the chlorine C2 form. So basically 2 chlorine, so here 2 electrons will be removed at the anode, and obviously this electron is taken by the sodium. Just for sodium here extracted, at the same time it's chlorine, it is reduced to Cl2, and the electron is this, which is utilized by sodium to get the sodium. And if obviously we simplify the reaction, then you get 2 sodium, here 2 electrons, and 2 sodiums form. But in this is for the sodium, magnesium, and calcium. But for the case of aluminium, it is obtained by electrolytic reduction of aluminum oxide. Here basically what we see the sodium, magnesium, aluminum. If we talk about them, then obviously they reduce by the from their molten chloride form. What is the basically the chloride here leaves the 2 electron that is taken with the sodium to form a sodium metal or metal. But in case of the aluminum, we use this oxide form. Now we have obviously seen this for the higher reactive metal, but now we see how we gonna extract, or we can say the purify a metal from its impure state. And how we can do is by electrolytic reduction. Now we take on the next page on the screen. So here we are, we're gonna see basically the define the metal. So as we know that we have copper, zinc, tin, nickel, silver, gold can be electronic refined. Why? Because we get some, like for example, if we have a copper electronic refined, basically if we have an impure sample of gold, then we can purify. How we can done this? Basically first of all we take a beaker, here we take a cathode, and here take an anode, and we supply here the electricity. Here the electricity. So basically this is the negative, this is the positive end, and the positive end is obviously the anode. The impure sample is here applied, and here the cathode pure sample is right. So basically what happened when we pass the electricity, then obviously from the impure sample the pure metal, and we here we taken the solution of, for example, solution of that compound electrolytic solution of the copper sulfur acidified. And now for example if we taken the copper sample, so the here the pure copper sample get dissolved, when the here the pure copper sample get deposited at the cathode end, but the passes of electricity at the same time the impurity that could dissolve at the anode. So basically, when you apply the electricity, then here the cathode and the pure metal goes to the deposit at the cathode, and the impure sample that get dissolved in the solution. And this is known as the anode, the impurities basically. So this is how the electrolytic refining is done, where we can take the copper, tin, zinc, nickel, gold, and silver. And how we refine it? Basically, we apply the pure sample to the cathode and impure to the anode, and we supply the electricity. Then this is all in the solution from the anode mud, and these are the impurities and the purities that get dissolved with the cathode. So this is how we can do the refining of metal.